Hello, I'm Sofia Herrador, a student of second year of Bachillerato of Sumaldapeta School, and I'm going to explain an exercise of physics optative work. The exercise that I have chosen is in the Unit 5 of our physics book in the page 151, the number 1, but I have changed it a little bit. This is my exercise. A man jumps in a springboard which has a length of 10 meters, a width of 1 meter, a thickness of 0.15 meters, and it is encrusted 5 meters. The man causes in the springboard a wave with a maximum height, the amplitude, of 0.5 meters. What will be the height in the moment 5 seconds? Well, here we can see the variables with their symbols. And here we have the moment that is going to be the variable of the movement. Then these are the calculus that I have followed to arrive to the result, that is the height. And this is the expression of the height. Okay, now we are going to go to the Excel, where we can see again the variables, the calculus, and the result. And we are going to start to study the variables. The first variable is the amplitude. And as we can see in the graphic, when the amplitude increases, the height increases exponentially. If we go to the GeoGebra, we will see how it moves. We are going to put an amplitude of, for example, 8 meters. And we press start. And we can see how the springboard moves. If we put a bigger amplitude, for example 14, we would see that the height increases. So as I have said, when the amplitude increases, the height also increases. Okay. The next variable that we are going to study is the length. Here we can see in the graphic that the length moves as a cosine. In the GeoGebra, we can put a length of, for example, 20 meters, and we can see this movement, that the springboard moves as a cosine. It vibrates. For example, in 25, we can see it better. And this make a wave, this vibrate. So we can say that the length has an important effect on the height in this case. The next variable that we are going to study is the width. We can see that when the width increases, the height decreases as a parabola. In the GeoGebra, if we put the variables in the equilibrium position and we put the width, for example, in 5 meters, and we press the start button, we can see how it moves. And then we can put a width of 15, and we can see how the springboard moves, but the height decreases. So as I have said, when the width increases, the height decreases. The next variable that we are going to study is the thickness. The thickness, the same as the length, changes as a cosine. So in the GeoGebra, we would see that the thickness, if we put 0.17 for example, we can see this movement, the vibration. So we would say that the thickness has an important effect in the height. Now we are going to study the incrustation, um, we can see that when the incrustation increases, the height decreases as a parabola. In the GeoGebra, we can see how if we put a length of 20, the incrustation is lower, and it moves very. I'm going to put the thumb to see it better. The movement is very slowly, so the height is not really high. If we put for example 25 length and 10 of incrustation, we would see how it moves like the vibration. And now we are going to put a minimum incrustation, and in the button of start we would see how the height decreases. So as I have said, when the incrustation increase here, the height decreases. So the variables that have an important effect on the result are the length and the thickness. If we go to the word, we would see that the length is down in the division of the natural frequency, and the thickness is on the up the division. So, and all the two of them make an important effect. So well, this has been everything. I think that you have learned a lot with this exercise. I with this link I would attach the Word, the Excel, and the GeoGebra, so that you can learn more. Thank you very much.